Hello everyone, welcome to the daily coding where we are going to go through majority element, which is actually a problem where we receive as input an array of integer and you're supposed to find out what are the elements that appear more than n divided by 3 times. This notation is actually the floor division of n by 3. What does that even mean exactly? Let us take this arrow for instance. We have 3 appearing 2 times and then we have 2 appearing 1 times. Now that 3 appeared 2 times, is actually 2 greater or equal to n divided by 3? Yes, n divided by 3 will be actually 1 in this case, and then 2 is actually greater than 1. So 2 is actually greater than 1, where 2 refer to the number of occurrence of 3. So that's why 3 is one of the solution. Now the number of occurrence of 2 is actually 1. 1 is not greater than 1, so that's why 1 is not part of the solution. So we just get rid of this and then we just take this one. Let us take another example. We have this array consisting of one element. The number of occurrence of this element is actually 1. Now we are going to compute, is 1 actually greater than n divided by 3? N divided by 3 is 1 divided by 3. That is going to give you 0.333. Yes, 1 is actually greater than this one, so 1 is part of the solution. We return 1. The same here, the number of occurrence of 1 is actually 1, which is greater than 0.33, which is greater than 2 divided by 3, which is 0.66, and the number of occurrence of 2 is actually 1, which is also greater than 0.66. That is why you have this array as a solution. Now that we have example, how are we going to solve it? Our first approach, our straightforward approach of solving this will be to count the number of occurrences of each of the element, and then after check if that number of occurrences is actually greater than the target n divided by 3. If it is the case, you just append it to a result array and then you return the array. What will it look like? So you create another map. So let me explain you so you see where we are going. So you have an array like this, and then you want to have a map like this, the map of occurrence. So each of the element, let's say this array has one time, 2, 3 times. So that's why 1 appear 3 times, 2 appear 3 times, the first, the second, and the third, and then the 3 appear just one time. So with this, you have your occurrence array here, and then you have the size here. And then do agree with me that 7 divided by 3 will actually give you 2 point something. And then now you're going to check, is actually this one greater than 2 point something? Yes, so you take this one. Is actually this one greater than 2 point something? Yes, so you take this one. Is actually the number of occurrence of this one greater than 2 point something? No, so you don't take this. So at the end you are going to return 1 and 2 because they are the element with number of occurrence greater than 2 point something, which is the size divided by 3. So the code will look like this. You have another map which is going to store your frequency. You look through your various number and then you increment into your map. Now you create a vector which is actually the element you are going to return, and then from that you look through your element of the map. The map is actually the structure that you previously used to add your occurrences, and then if the size of the element is actually greater than n divided by 3, I just pass the 3 here, is the same. You add the element to the result and then you return the result. So basically this is our first approach of solving this, which is really straightforward. Now you have a follow-up here saying that could you solve the problem into linear time and big of one space? What we have is actually a linear time, which is nice, but it's not big of one space. How can we achieve big of one space in this scenario? So for us to achieve big of one space, we need to think of the problem differently. Let us dive in. So for this second one, my approach will be as follows. So I know that I have an array where we have a couple of elements with various proportion, right? And then if you are a solution, let me grab this. If you are a solution, that means your number of occurrences appear greater than n divided by 3. We are 100% sure that we cannot have more than 3 solutions. Why is that? Because the number of occurrences of the first one is actually greater than n divided by 3, and the number of occurrence of the first one is greater than n divided by 3. The number of occurrence of the second one is n divided by 3. If you have a third one which has a number of occurrence also n divided by 3, you are going to have an array of size n with a number of elements greater than n, which doesn't make sense. You can even use arithmetical formula that prove that r, in fact, the rest of the element apart from the two solution is actually less than n divided by 3, which cannot be a solution. So basically we are 100% sure that we have just two solutions. This is the first thing. Now that you are 100% sure that you have just two solutions, how are you going to find them? So you are going to use a loop where whenever you found, okay, let me get this so you see better. So the idea here will be to create two potential elements which are going to store the potential element, and then you are going to have the corresponding count of each of those elements. And this loop that we are going to do here, we are going to loop through the element, and the idea will be to increment the number of count of each element that we are going to see. And if we find ourselves seeing an element which is not the potential first element and not the potential second element, we decrease both the first and the second, because we want to make sure that at the end of the day we have the P1 and the P2 reflecting the element with the highest occurrence in the array, right? So at the end of the day we are going to have those P1 and P2 reflecting the element with the highest occurrence in the array, but they are not actually referencing the exact occurrence of P1 and P2. That is why you need another for loop here to kind of have the accurate occurrence of P1 and P2, and then now you are going to check if that occurrence is greater than n divided by 3. If it is the case, you consider it as part of the solution. If the second one is also passing the check, you consider it as one of the solution, and then you return the result. This was my approach of solving this. I hope you do enjoy it. Feel free to leave me a message in the comment section. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.